Hello out there, Physics 277 students and any viewers on YouTube who may be watching this video. This will be video 9 in our series of how to use the Linux command line interface. And in this video, we're going to be talking about pipes, T's, and the use of the commands history, grep, and wc, or word count. Now, pipes are going to be a very powerful tool in the Linux command line interface that are going to allow us to direct the output of one command to the input of another command. And doing this, we can set up very powerful strings of commands, so to speak, or a pipeline of commands that can process data or process files. And I'll show you some examples of that here today. Now, what is a pipe? Well, first let me appeal to what we've previously done in a previous video, and I'll put a link to that video in the upper right hand corner of this video near the end of it, where we talked about standard in, standard out, and the redirection of both standard in and standard out. And how did that work? Well, we learned, for example, that when we had a command like ls, what ls did was write its output to standard out. And if we chose to, we could capture that output and redirect it into a file. And the way that we did that, here's an example. I said ls, use the right angle bracket or the redirect symbol or the greater than symbol, depending on how you want to refer to it, and the name of a file that I wanted to use to capture the output. So here I'll just say output.txt. And when I did that, the command executed. We didn't see any output, and the output instead was sent into this file named output.txt. I can name the file whatever I want. I just chose to name it here output.txt. Well, what if we wanted to send the output that ls wrote into another command that accepted input from standard input? Well, there's a way to do that. On a Linux shell, that's through the use of what we call a pipe. Right? Now, the pipe is symbolically going to be denoted here by the vertical bar character, this thing that you see right there on the command line I've typed. Where do you see that on your keyboard? On most keyboards, that is above the backslash key here, and it's just above the enter key where you see it there. So you usually have to hit shift backslash to get that on most keyboards. Your keyboard may be somewhat different, especially if you're using a laptop, but look around, you'll find it there. All right, it may not be a solid bar. It may look like two vertical bars spaced one above another and the symbol that's used on the key, but you can generally find that. And the way this is going to work is if we have a command, let's say it's command 1, and it writes its output to standard out, we can tell the shell to take the output from command 1 and send it into another command that accepts its input on standard in. Let's say we have a command named command 2 that accepts its input on standard in. What we could do is hit the vertical bar there and then say command 2. All right. So what happens here is command 1 is executed, the shell captures its output, and it sends the output from command 1 into the input, that is the standard in, so that it can be used by command 2, which will be executed after command 1. All right. Let's look at a real example, not just this abstract thing which I've ginned up here. How will this work? Let's take a command which we're very familiar with, the ls command. I'll do ls, and we see I have a big list of files here in this directory. All right, these are older Fortran files, so they end with a .f in them, but let's not worry about the content of the file so much. All right, what could I do here? What if I wanted to see this list of files from the ls command, but I wanted to see it one screen full at a time rather than have it all scroll by so fast? What I could do is I could type ls, put a pipe to redirect the output of the ls command into a command that would allow me to see it at one screen full at a time. Well, what commands would do that? I could use the more command or the less command would also work. But when I do that, now I see the list of files that's present in this directory one screen full at a time. I just keep hitting spacebar till I've gone through the entire list. And I can hit Q to quit out of the more command at any time I want. So that's a very useful thing that I like to be able to do. Another context where we'll use pipes and use them fairly frequently is, for example, here's another command that's very useful. You can look back and see all the commands you have previously executed in the shell. There's a built-in command in the shell called history. When I type history, it just literally writes out to the screen all the commands that I have previously executed. So there they go. In this case, I have roughly 1,064 commands in my history list. All right, you can change the size of that, and that's controlled through a shell variable. That's another video that you can watch if you haven't seen it so far about how to look at shell variables and environment variables and how they can be used to control commands. So the history here is quite extensive. I've got 1,000 commands. Now, what if I wanted to see it a screen full at a time? Well, I could just type history and pipe that into the more command, and now I can see it a screen full at a time. And I'll just quit out of here. I don't want to page through that entire list of 1,000 commands. What if I was only interested in the ls commands or the cd commands or the cp commands or something like this? All right, is there a way that I could filter these so that I can only see those? And the answer is yes, and it's through the use of a really cool Linux and Unix command called grep. The way that grep works is we type the command grep, and then we give it a string of characters that we want it to look for. So for example, I could have it look for ls here. And then as its input, I can give it input in one of two ways. I could either give it a file name here as the third argument, or second argument I should say, or I could take its input from standard in. All right, and I could redirect it from a file using standard in, or I'm going to be able to use that with a pipe. Let's first see how this works on a file. Let's look at do an ls again, look at the files that I have present here. I have a file named update.f. It's an old style Fortran file, and there should be some things in there. There should be a line that says implicit none. It's a Fortran statement you typically would find in a file. Let's see if that line is present in the file using the grep command. We'll say grep, and we'll search on the keyword implicit here, and I'm delineating that string of characters that I want it to search for using single quotes here, and then I'll give it the file name, update.f. When I execute this, it comes back and it says, yes, I'll print the line of the file where I found that, and it found it on a line that said implicit none here. Once we learn Fortran, or if you've already learned Fortran, you'll know what that means. If you haven't learned Fortran yet, when we get to it, we'll learn what implicit none means. But it found it actually even colorized it here on this particular terminal and made it look red so it stands out. I could search for a different string if I want. Let's search for, typically a lot of Fortran subprograms would have a keyword in there, return. I'll search for that, and indeed, basically, I have a keyword in there called, or a line in there that has the command return, the statement return in it. All right, so that's how I use grep with a file, but grep can also accept its input on standard input. Let me illustrate that. What I'm going to do here is I'll say cat and use that same file, update.f. And that would normally write its output out to the screen here. But I could then pipe that into grep and search for a string there. Let's search for that return again. Let's see if we find it this way. This way, I'm only giving grep a single argument, not two arguments. There's no file name here for the second argument. It's taking its input from standard input instead. All right? And indeed, it found that line that we previously had already found using grep in the other form. All right, so grep is a very useful command. It can filter lines out of a stream of input that has a specific character string in it that you tell it to look for. So let's use that together with the history command. What I'll do is I'll say history, I'll pipe this into the grep command, and I'll search for a command like ls. And what this should do is it should give me all the ls commands that I have executed previously. History is going to list all my commands and send them as an input to grep, and grep is going to print out the ones where there is the string ls in the command. Let's see if that works. And indeed it did. All right, it gave me a list of all the commands here have the string ls in them. You can see they're all highlighted in red here. Now, there's a lot of them. Could I basically see them one screen full at a time? Yes, I could. Here what I'll do is I'll take the output of grep, which writes its output to standard out, and I'll send that output into the more command, like this. So now I see all of my ls commands one screen at a time. All right. I can string together as many commands as I want. In this case, I did 3 commands, history, grep, and more, all in one line that I executed on the shell, on the command line interface. All right, I can string together an arbitrary number of commands to do things that I want here by basically taking the standard output from one command and sending it to the standard input of another command using pipes. In this case, I used 2 pipes. This first pipe right here connected the history command to the grep command. The second pipe right here, oops, right there, connected the grep command, the output of the grep command, and sent it to the input of the more command. All right, so this is very useful. Could this be used together with redirects? Yes, it could. Watch this. Let me redirect the output of the more command here, which writes the standard out, to another file. I'll call it output2.txt. Right? When I did that, you'll see nothing got written to the screen. The output that previously came from these three commands, which are strung together using pipes, that was normally written to the screen as we had seen here before, this time was sent to the file output2.txt. To prove that, let's just do a more on output2.txt, and there you have it, written out to the file. Now, there's another way we could do this, and that's a very useful command that we can employ together with pipes, and it's called the T command. That is T-E-E. And the way that T works is it takes one argument, and that's the name of a file. So if I said here output3.txt, what T would do is it would take any input that was given to it on standard in, right, and it would write it to that file output3.txt, at the same time writing that output to standard out as well. And why that's useful is we can insert it into a set of commands that we're executing in a pipeline, and we could write out the results to a file at the same time writing it to standard out so we can further process it. Let me show you an example. Let's go back and use our old friend the history command, which is going to give me a list of all the commands that I have. All right. I can redirect the output here using a pipe into the T command. Then I can give the T command a file name. Let's say output3.txt. This is going to take its input. T will take its input, which it receives on standard in, send it out to the file output3.txt, and it will also send it back out to standard out. So it sends the output to two places, one to the file, one to standard out. I can then pipe that standard out into another command here. Let's say grep, let's say cp. I'll search for all the commands that basically were executed with cp, and let's see what we get. All right, I got the commands that were executed with cp in them, but let's look at the file more output3.txt, right? And there are the entire list of commands. So T, it was very useful as a command. It sort of split the pipeline into two parts. Right here, it took the stream of input that it was getting right here from standard in from the history command. It took that stream and it wrote it out to a file output.txt, and it meanwhile sent that stream to standard out so I could further pipe it into the grep command to search for CP. And I could, if I want, string together a fourth command here. I could see that output one screenful at a time. So now I've got three pipes connecting four commands, and I can do that and see all of it, and it works that way very smoothly. And this is one of the features that allows the Linux command line interface to be a very, very powerful tool. All of the commands usually accept standard, many of the commands I should say, accept standard input. Most of them write their output to standard output except for error messages. And we can connect those commands together. We can plug them together like Legos, where we just plug the output of one command into the input of another command and connect them to do very powerful things. Process a lot of data, manipulate that data, manipulate files. We're going to see how to do that later. And this makes this Linux command line interface a very, very powerful interface for processing large numbers of files or handling large amounts of data. So with that, I'll stop for right now. Oh, let me show you one more thing if we haven't mentioned it. I did mention I was going to show you, and then I almost forgot to do it. There's one more thing that's very useful here, which is the WC command often used together with pipes. What does WC do? The usage of WC is normally you would say WC and give it a file name. Let's give it that file update.f. And what it will do is it will give me a count of words, lines, and characters in the file like this. All right, in this case, when I say WC, it tells me there were 69 lines in the file, basically 193 words and 1,790 characters in that file. I can use that to just get the number of lines in a file. If I say WC minus L is an option to WC, it just gives me the number of lines. So for example, I wanted to do a history command and find out how many times I had executed a command with the string ls in it previously. What I could do is I could basically just grep ls here, like this, and then I could pipe the output into WC minus L, and it would tell me how many lines there were where that character string ls appeared in it. In this case, there were 196 in my history lines that had the character string ls in it. So these three commands, grep, history, WC, all work together very nicely. They're all connected by pipes, and this is the kind of thing we can do with pipes on the Linux command line interface. So I'll stop for now. If you have questions about this, if you're one of my Physics 277 students, certainly you could see me during office hours. But if you or one of the other viewers out there who may not be in the class have questions, you can also post on the comments section of this video, and I'll be happy to answer those. I'll try to answer that as quickly as I can. Or if you have comments on the video, you'd like to see other things, please post a comment and I'll be happy to entertain that. Otherwise, and if you like this, please click subscribe and I'll be posting more videos in the future. Otherwise, I'll see you here next time.